Hello, welcome to Maths class. My name is Olujimi Gabriel. Today we'll be talking about indices. And before we move to the topic, the objective of this topic is to be able to simplify numbers and expression written in an index form. Now, laws of indices. Look at, when you have 10 times 10 times 10 in 3 places, the answer will be given as 10 raised to power 3. That is, the number of 10s you multiply will determine the index power. This 3 is what we call index, where 3 is the index or power of 10 raised to power 3. 10 to the power of 3, that is what we call index. Now, you can see you have 10 multiply in 3 places. The short form is what we call the index form. Now, similarly, when you have P in 4 places, 4 is the index of P in the expression P raised to power 4. We often say P to the power of 4, that is P raised to power 4. The plural of index is indices. Now, how to do multiplication of indices? We have x raised to power a times x raised to power b. Now, look at, we are to multiply x raised to power 5 by x raised to power 3, a raised to power 3 by a raised to power 2, and y by y raised to power 4. Don't forget, when you have y alone, it means y raised to power 1. Now, look at, this is x to power 5. This is x to power 5 times x to power 3. X to power 3. By the time you multiply everything together, you count 1, 2, 3, 4, 5, 6, 7, 8. That means x raised to power 8. That is how to do multiplication of indices. Now, look at, when you have a raised to power 3 times a raised to power 2. Look at, this is a to power 3 and this is a to power 2. By the time you multiply everything, it's just like counting the number of a's that you have. Then you have a raised to power 5. That is that. Now, y times y raised to power 4. Look at, by the time you multiply this together, you have y raised to power 5. But when you notice something, notice that when you multiply 2 indices together, you can see this is the number, like we are using letter now. The letter is x, and their powers are different. But since we have the same letter, we can as well take one of the letter, then you add their index or power, like what you have here, that is x raised to power 8. That is, you can always do that in a quick form without having to go through this expansion method. What we did here is actually expansion method. Now, look at the second one too. A power 3 times a to power of 2. Look at, since they are of the same letter, take one of the letter, you do the addition of their index. We have a raised to power 5. The same thing with when you have y times y raised to power 4. Y standing alone is also means y to the power of 1. Now, since we have the same letter, you add their power together. That is y to the power of 1 plus 4. We have y to the power of 5. Now, in general, anytime you have x raised to power a times x raised to power b, you should know that you add their power together to give you your answer. This letter could be any letter, while this power could be any number. For example, 2 raised to power 3 times 2 raised to power 4. Your answer will be 2 raised to power 7. That is how to do multiplication of indices. Now we move. Look at this following example. We have 10 raised to power 4 times 10 raised to power 2. Now look at, using the expansion method, look at this 10 to power 4 and 10 to power 2. By the time you do the multiplication, you have 10 to power 6. The same thing when you have 4c raised to power 3 times 7c raised to power 2. You can see, just like we did in algebra, we have algebra contains both letter and numbers. Now look at what we have here. We use our long multiplication, that is 7c, 7 times c times c times c. That means we have c into 3 places, times 7 times c times c. Before you do that, always arrange the numbers first, followed by the letters. Now 4 times 7 will be 28. When you multiply all the c's, we have c raised to power 5. Now 28 times c raised to power 5 will be equals to 28c raised to power 5. Or in a more quick way, you have 10 raised to power 4 times 10 raised to power 2. Since we have the same numbers, take one of the numbers down, then you add their power, which is equals to 10 raised to power 6. Is that okay? Now, the same thing here. Just arrange the numbers first. 4 times 7 times c. See, we have c here, we have c here also. Then you add their powers together to get 28c raised to power 5. You can see, we still have the same answer as when we use our expansion method. But it now depends on which method you think is very fast. But I would suggest you use this depending on how you can handle it. Now, we now move to division. How do we do division when used with indices? Now, this is example. We have to divide x raised to power 5 by x raised to power 3, a raised to power 7 by a raised to power 4, and p raised to power 6 by 6 p raised to power 5. I believe you know our division. Look at this line is our division line. X raised to power 5 at the top, while x to the power 3 at the bottom. By the time you cancel out, this cancel out, this cancel out, this cancel out, this cancel out, what you will be left will be x times x. And x times x equals to x squared, or x raised to power 2. The same thing with a raised to power 7 divided by a raised to power 4. Now, look at, this is our division line again. Now, at the top, we have a times a times a times a times a times a times a. And as our denominator, we have a times a times a times a times a. Now, by the time you cancel out, 1, what you have left is a times a, which is equals to a raised to power 3. Now, the last one is p raised to power 6 divided by p raised to power 5. Look at it here. This is another way of writing it this way. Now, you use the expansion method. P times p times p times p times p times p. And at the bottom, we have p to the power of 5. By the time we cancel out, our answer will be what? P. What you have left is your answer. Again, when you notice that when we did the division here, it look like minus. Take a look at P. You know, the one we did before was addition. Now, this one now take the form of a subtraction. Now, in a more quick way, x raised to the power 5 minus 3 equals to x raised to the power 2. That is, whenever a division, you divide an indices, you subtract their power to get your answer. Look at what we did here also. A raised to the power 7 divided by a raised to the power 3. Then you subtract their power. Minus 4 equals to a raised to the power 3. The same thing applies here. In general, x raised to the power a divided by x raised to the power b will be equals to x raised to the power a minus b. That is, when you have two indices, you subtract their power to get the value of the division. Now, example. We have to divide 10 to the power 6 by 10 to the power 2. Then 12a raised to the power 7 by 3a raised to the power 2. Now, just as before, our normal expansion, 10 times 10 times 10 times 10 times 10 times 10 times 10. This is our division line divided by 10 times 10. By the time you cancel away, you have 10 raised to the power 4 as your answer. Or, look at, when you have 10, make sure those numbers are of the same number so that it can be easy. Now, 10 raised to the power 6 minus 2 equals to 10 raised to the power 4. Since they are the same, just take one of the numbers and subtract their power. The same thing applies here. First of all, 12 is raised to the power 7 divided by 3a raised to the power 2. Now, look at, since we have numbers and letters together, we first of all do the division of the numbers times, then you now take the ones that has indices. Now, a raised to the power 7 minus 2 equals to 4a raised to the power 5, because 3 here 1, 3 here 4. Now, 4 times a raised to the power 5 will be equals to 4a raised to the power 5. Now, 0 and negative power. Example. Simplify x raised to the power 3 divided by x raised to the power 3. We have to do it in two ways. By fully expanding each term, just like what we have been doing before, by subtracting indices. Now, look at, the first one is this. X times x times x all over x times x times x equals to 1. Like I told you before, now, when you now do the subtraction of indices, you have, when you are dividing, that means you subtract the power of the indices. Now, look at, I told you from here that when we use expansion method and subtracting indices, we still have the same answer, 10 raised to the power 4 and 10 raised to the power 4 here, as you can see. 4 raised to the power 5, 4 raised to the power 5. That is, when we use expansion method and subtracting indices, we will still have the same answer. That is, the answer are equal. Now, look at this place. When we use the two value, one is 1, the second one is what? X raised to the power 0. Always take note of this. When we divide, when we use expanding method, our answer was 1. And when we subtract the indices, our answer is x raised to the power 0. Now, from A and B, it shows that x raised to the power 0 equals to 1. Now, in general, any number raised to the power of 0 has the value of 1. For example, 2 raised to the power 0 equals to 1. 10 raised to the power 0 equals to 1. 100 raised to power 0 equals to 1. Any number or letter raised to power 0 equals to 1. A raised to power 0 equals to 1. B raised to power 0 equals to 1. C raised to power 0 equals to 1. Any number raised to the power of 0 equals to 1. Now, again, simplify x squared divided by x raised to power 5. Again, using fully expanding each term and by subtracting indices. By subtracting indices, we have x times x, x squared, that is x raised to power 2 equals to x times s, divided by x times x times x times x times x. Now, when you divide, you have 1 all over x raised to power 3. Right? Now, when you use subtract indices, x squared minus 5. From our number line knowledge, we know 2 minus 5 equals to minus 3. Now, from A and B also, you know that x raised to power minus 3 equals to 1 all over 3. Now, in general, x raised to power minus A will be equals to 1 all over A. That is, anytime you have 2 raised to power minus 1, to remove this minus, it has to be 1 all over 2. Any number, when you have 100 raised to power minus 1, it will be equals to 1 all over 100. Any number, just like what you have here. Please take note of that. Now, to summarize, the laws of indices are, we have multiplication law, division law, the power 0, and negative power. All these laws are what we'll be using from now till tertiary educational level. They will not change. They are still not changed. Is what everybody is using as far as law of indices is concerned. Now, this is the first one we established. This is the second one, the third one, and the fourth one. That is, any number raised to power 0 equals to 1. When you have a negative power, that means it will be reciprocal of that indices, which is what you are seeing here. 1 all over x raised to power a. You can see, to remove this minus, it has to be 1 all over x all over a. Take note of this law. Example. Simplify the following. 10 raised to power minus 3 x raised to power 0 times x to power 4 times x to power 2. A raised to power minus 3 divided by a raised to power minus 5 and 1 all over 4. You can see this 1 all over 4 is inside the bracket, raised to power minus 2. That means this thing is affecting both 1 and 4 because they are fractions. Now, look at 10 to raised to power minus 3 equals to 1 all over 10 raised to power 3, which is equals to 1000. That is 10 times 10 times 10 equals to 1000. Now, look at it again. X raised to power 0 times x to power 4 times x to power minus 2. Now, look at, you can see they are of 3 in number. So the same thing still apply. Since they are the same, you just add all the indices together because we are dealing with multiplication here. Don't be carried away with the minus you have at 2. Since this is what we are dealing with, multiplication. Now, 0 plus 4 plus open bracket minus 2, because we are dealing with what? Multiplication. Multiplication. That means we are using addition. That is why we have plus open bracket minus 2 here. I use minus because we are dealing with two different type of sign, which are plus and minus. 0 plus 4 will still be 4. Now, when you use this plus to open this bracket, it will be minus. That will be 4 minus 2. So our answer equals to x raised to power 2. C. A raised to power minus 3 divided by a raised to power minus 5. You can do it this way. I told you a to power minus 3, same thing as 1 all over a raised to power 3 divided by a to power minus 5, it will be a raised to power 5. Now, I can turn this division to times by saying a raised to power 3 times a raised to power 5 all over 1. That is, you change what you have here. What you have here will become the denominator, while the denominator will now become the numerator. Now, using our normal division, you can now subtract, because we are dealing with what? A raised to power 5 all over a raised to power 3. Since it is division, when you subtract their power, it will be a raised to power 2. Or you can choose to do it this way, like you have here. It will be minus 3, because we are dealing with division, minus open bracket, this one is minus 5. When you use minus to open this bracket, it will be plus. That will be minus 3 plus 5. And which is something as saying 5 minus 3, which is equals to 2. That will be, our answer will be a to the power of 2. Now look at the last one that we have here. We have open bracket 1 all over 4 to the power of minus 2. Now, to remove this minus, we introduce 1 all over the bracket squared. Look at it here. The bracket squared. And when you square the bracket, 1 all over 4 times 1 all over 4 will be equals to 1 all over 16. Now, I can choose to write it this way to make it more simpler. Now, I will now change what is down. I will interchange them to become this. My answer will now become 16. That is that. I believe you get that simple steps. Now, simplify again. 2a raised to power minus 1. Don't forget, when you see bracket outside, then you have minus 1 at the top. That means this minus 1 is affecting the content of the bracket. Look at, you can see it here, times 3a squared. Now, you can write it as what? 3a squared all over 2a. Then use our expansion method, 3 times a all over 2 times a. Now, when this one cuts this, we have 3a all over 2. That is our answer. All these things are simple than what you can just play with at home. Now, assignment. Simplify the following. P raised to power minus 2 divided by P raised to power minus 7. A raised to power minus 2 times A raised to power minus 3. Now, 2 raised to power minus 1 times 3 brackets 3a close bracket raised to power 2. You can see this is 2 raised to power minus 1. Don't forget, this minus 1 is for this a only. To write this, it will be 2 all over a times this content. You can see this bracket, this 2 is affecting the content of this bracket. That will be 3a raised to power 2. That is that. Now, for further reading, get Junior JSS2 Maths textbook from page 23 to 26. for more exercise and more knowledge on that. Till I come your way next time. Thank you for your time and enjoy your day.